Hello, and welcome back to ISOmath. Today we're going to talk about addition and subtraction formula for sine. What is O? And in order to do the addition formula for sine, we need to first draw back on what we've done, the work that we've done with the subtraction formula for cosine. But before we even do that, we need to revisit some properties we know about sine. We can say that the sine of an angle is equivalent to the cosine of half pi minus that same angle. Again, this is something we learned in previous sections, as well as we can also say that sine of half pi minus an angle is equivalent to cosine of an angle. And this identity is going to help us to rework. If we go back here and we look at their cosine value here, the subtraction formula for cosine, what we're ultimately looking for is this. So the addition formula for sine simply is going to be sine of u plus v, and that's what we're looking for. But notice that we can rewrite this equation as simply using our identities down here, as that's nothing more than cosine of pi over 2 minus that angle of u plus v. And given that a little more rework, I can say that's equivalent to cosine of pi over 2 minus u minus v. And if I separate even more, I can group together a little bit better. I can say that that's pi over 2 minus u and minus v. So essentially what I'm doing here is I'm essentially calling this guy right here my u and this guy right here my v. And you can see I am now set up to put it into this is equivalent to my subtraction formula for cosine. So when I rework this guy now, it comes out looking like this. Cosine of the u part, which is pi over 2 minus u, times the cosine of v, plus the sine of the u part, which is pi over 2 minus u, times the sine of v. So that is that body reworked, and essentially that is essentially the same as we should be comfortable with knowing that this value right here, this cosine of half pi minus u, takes on that property. So that's nothing more than the sine of that u. So we're left with this: sine of u, cosine of v, plus cosine of u, because that's what that value is, times sine of v. So that is essentially what my addition formula for sine comes out to be, right there. And again, utilizing my substitution and identities, that's how I end up coming up with that equation. To find out the subtraction formula for sine, I'm going to use the same idea that I use for the subtraction formula of cosine, and that's simply drawn on prior knowledge that I can say that the cosine of a negative angle, cosine negative v, is equivalent to cosine of the positive angle, or cosine v, and likewise sine of negative v is equivalent to negative sine of v, something that we learned in previous sections. So going through here, I'm going to rewrite this, and wherever I see, I'm going to come down and I'm looking for obviously sine of u plus a negative v is what I'm really looking to, which we did in previous section, which is nothing more than sine of u minus v. So that's going to come out to being obviously sine of u, cosine of a negative v, plus cosine of u times sine of a negative v. And again, that's a v. Going back and drawing on these properties, that essentially comes out to being nothing more than sine of u, cosine of v, minus, because this is going to come out, this part right here is going to come out to being a minus v, so minus cosine of u sine of v. And again, that minus sign carries out in front of there. So this ends up being my subtraction formula for sine. Okay, in this example we're asked to find the exact expression for sine of 15 degrees. Well, using the formula we just derived, which is the sine of u minus v, I know I got to come up with these quantities. So essentially what I need to do is I need to find a way to get to 15 degrees And because it says exact expression, I want to draw on some prior knowledge that I already have. So I want to find two angles when subtracted to each other gives me the 15 degrees. And we can do that identifying that as the same as 45 degrees minus 30 degrees. And again, these are special angles, and they're angles we should know. So essentially I'm saying my u value is 45 and my v value is 30. So obviously this 45 degrees corresponds to my u value, while the 30 degrees corresponds to my v value. So I'm going to need to find out for my u values, both my u values, I need to find out the cosine of u, or I need to find the sine of u, which is the u value is 45 degrees, which we should know is the square root of 2 over 2. And I also need to find out the cosine of that u value, which is 45 degrees, which is also the square root of 2 over 2. But then for my v angles here, which is 30 degrees, I need to find out the sine of 30 degrees, which is, we know, is 1/2. And I need to find the cosine of 30 degrees, which is the square root of 3 over 2. So I have my u values and my v values, and now it's simply about plugging and chugging and putting back in. So my sine of u, in this case, is square root of 2 over 2, times cosine of v right here is square root of 3 over 2. And that's going to be subtracted from my cosine of u, which is the square root of 2 over 2, times my sine of v. Sine of v right there is 1/2. And going through my math, I know that comes out to being the square root of 6 over 4 minus the square root of 2 over 4. And that comes out to being the square root of 6 minus the square root of 2 all over 4. And there, oops, that looks ugly, but that's my 2. That is my exact expression for the sine of 15 degrees. And I hope these have helped. And remember, check back to ISOmath for all your math needs. And we'll see you soon.